Hello. Close your eyes. Take a deep, slow breath in and let it out. Sink into the surface beneath you. Let your shoulders drop. Tonight, we are going on a journey. Not a journey across the ocean or through the vastness of space. Instead, we are going to travel through time, tracing the history of an idea. It is perhaps the greatest story of human ingenuity. The story of how we taught sand to think. For thousands of years, humans have looked up at the stars and wondered if we are alone. But we also looked at our own hands, at our own minds, and wondered, could we create something like us? Could we build a machine that doesn't just lift weights or weave cloth, but one that remembers? One that reasons? One that dreams? What we call artificial intelligence today feels like magic. It feels like it arrived overnight. A sudden spark in the dark. But the truth is much slower, much quieter, and much more beautiful. It is a story of slow, patient progress. Of generations of men and women who planted seeds for trees they would never see grow. So, relax, let go of the day. As you drift to sleep, let me tell you the long, quiet story of the thinking machine. From its ancient myths to its brilliant future. Chapter 1. The Myth and the Mechanism, Antiquity to the 1800s. Long before there were computers, there were dreams of artificial life. In ancient Greece, they told stories of Talos, a giant bronze automaton forged by the gods to protect the island of Crete. They dreamed of mechanical servants made of gold. These were myths, of course. The human imagination stretching out, imagining a world where the burden of labor could be shared with creations of metal and fire. As centuries passed, myths slowly gave way to mechanics. In the workshops of the Renaissance, inventors built intricate clockwork automata. Beautiful, delicate machines. Mechanical birds that could sing. Wooden dolls that could dip a pen in ink and write a letter. They were marvels of gears and springs. But they were just illusions of life. They could only repeat the same actions over and over, trapped in the physical logic of their gears. The real shift began in the quiet, foggy streets of Victorian London in the 1800s. A mathematician named Charles Babbage designed a machine he called the analytical engine. It was a computer made of brass and steam. It was never fully built in his lifetime, but it caught the attention of a brilliant young woman named Ada Lovelace. Ada looked at Babbage's designs and saw something no one else did. Babbage saw a calculator. Ada saw a canvas. She realized that if a machine could manipulate numbers, and if those numbers could represent other things, like musical notes or letters of the alphabet, then the machine could compose music or write poetry. She wrote the first algorithm for this machine. In doing so, she became the world's first computer programmer, over a century before the first electronic computer was even built. Chapter 2. The Birth of a New Science, the 1940s to 1950s. Time moved forward. The brass gears gave way to vacuum tubes and electricity. In the 1940s, during the shadows of the Second World War, a mathematician named Alan Turing asked a simple, profound question. Can machines think? Turing was a quiet, brilliant man. He imagined a test, a game of imitation. If a human could have a conversation with a machine hidden behind a wall and could not tell if they were talking to a machine or another human, then, Turing argued, we must concede that the machine is intelligent. This idea planted a flag in the ground. It gave scientists a goal. In the summer of 1956, a small group of researchers gathered at Dartmouth College in New Hampshire. It was a quiet, warm summer. They walked under the green trees, drank coffee, and discussed mathematics. At this conference, they coined a new term. They called it artificial intelligence. They were incredibly optimistic. They thought that if they just spent a few months writing the right code, they could solve the mysteries of language, vision, and reasoning. They thought they could map the human mind in a single summer. They were wrong, of course. The human mind is a deep, dark ocean. And they were just standing on the shore, looking at the waves. Chapter 3. The long winters, the 1960s to 1990s. What followed were decades of hard, slow work. In the 1960s, computers were massive. They took up entire rooms. They were slow, and their memories were infinitesimally small. Researchers tried to teach computers to translate languages or to play chess. They built programs called expert systems, machines that were given thousands of rules. If this happens, then do that. It was like trying to teach a child to ride a bike by making them read a physics textbook. You can teach a machine the rules of a game, but you cannot easily teach it common sense. You cannot give a machine a rule book for how to understand a joke or how to recognize the face of a friend in a crowded room. Because of these limitations, the excitement faded. Funding dried up. The world lost interest. This period was known as the AI winter. The labs went quiet. But under the snow of those winters, the seeds were still alive. A few stubborn scientists kept working. They shifted their focus away from teaching computers strict rules. Instead, they looked at biology. They looked at the human brain. The brain is made of billions of neurons connected in a vast, complex web. What if, they thought, we could build a digital version of this? A neural network. What if we didn't give the machine the answers? What if we just gave it data and let it figure out the patterns on its own? It was a beautiful idea. But for a long time, it didn't work. The computers were still too slow. The data was too scarce. The winter dragged on. Chapter 4. The Data Awakening, the 2000s to the 2010s. And then, the world changed. The internet was born. Suddenly, humanity was generating data at a scale never seen before. Billions of digital photographs, millions of books, articles, and conversations, all uploaded to the digital ether. At the same time, computer chips, especially the ones used for video games, called GPUs, became incredibly fast. The snow of the AI winter began to melt. Researchers dusted off those old ideas of neural networks. They built deep, complex models and fed them massive amounts of data. In 2012, a major breakthrough occurred. A neural network called AlexNet was asked to look at thousands of images and identify what was in them. Cats, dogs, cars, ships. It performed with an accuracy that shocked the scientific community. The machine was no longer just calculating. It was beginning to perceive. Slowly, these networks crept into your daily life. They were the invisible hands recommending a movie you might like. They were the quiet voices translating a web page from French to English. They were the systems helping your smartphone camera take a clearer picture in the dark. The progress was steady. It was the era of the specialist. Machines that were very, very good at one specific task, but nothing else. A chess-playing AI could beat the world champion, but it didn't know how to play checkers. It didn't even know it was playing a game. Chapter 5. The Generative Era. The 2020s and Present Day. As we moved into the 2020s, a new architecture emerged. It had a strange name: the Transformer. This new way of building neural networks allowed the AI to understand context, to see how words related to each other across long paragraphs, to understand the relationship between a pixel of an image and the text describing it. We fed these new models the entire public internet. We let them read all of Wikipedia, all the classic books, all the scientific papers, all the poetry. And something astonishing happened. The machines stopped just analyzing. They started generating. You could type a sentence, a prompt, asking for a picture of a futuristic city at sunset, and the machine would draw it. A completely original image conjured from the mathematical patterns it had learned. You could ask it to write a sonnet, or explain a complex physics problem, or write computer code. Large language models, like the early GPTs and later systems like Gemini, became conversational partners. We moved from an era where we had to learn the language of computers, coding, to an era where computers finally learned our language. By 2026, these systems became fully multimodal. They didn't just read text. They could see video, hear audio, and understand the world in a unified way. They became co-workers, assistants, and sounding boards. But behind the magic, it is still just math. It is the culmination of Ada Lovelace's dream. A machine using numbers to represent the vast, complex beauty of human knowledge. Chapter 6. The Gentle Outlook, the Future. So, where does this long journey take us next? As you drift deeper into rest, imagine the world of tomorrow. The future of AI is not loud or chaotic. The true future of technology is invisible. It fades into the background, becoming a quiet, helpful layer over our lives. Imagine healthcare that is truly proactive. AI systems that can analyze your unique biology and catch the earliest. faintest whispers of illness years before you feel sick. Imagine new medicines designed in days rather than decades. Because an AI could fold millions of proteins in a virtual simulation. Finding the perfect cure for you. Imagine education that bends to the mind of the student. A patient, tireless digital tutor for every child on Earth. Adapting to how they learn best, moving as slowly or as quickly as they need. We are building tools that will help us solve the puzzle of clean energy. Tools that will help us navigate the stars. Tools that will help us understand the deep oceans. AI will not replace the human spirit. It will free it. By taking on the heavy lifting of computation and administration, it leaves us with the things that machines cannot do. The things that make us human. Empathy. Love. Article. Connection. The warmth of a shared laugh. The comfort of holding a hand. The thinking machine is a mirror, reflecting our own intelligence back at us. It shows us how remarkable our own brains are. It is the greatest monument we have ever built to our own curiosity. And so, the story continues. The servers hum quietly in massive data centers around the world, processing, learning, finding patterns in the dark. But you don't need to find any more patterns tonight. Your processing is done. The journey from the brass gears of the 1800s to the neural networks of today was long. It took patience. It took time. And just like that progress, your body needs time to rest, to heal, to reset. Let the history of the thinking machine fade away. Let the numbers and the algorithms dissolve into a soft, quiet static. Take one more deep breath in and let it out. You are safe. You are resting. The world will keep turning, the machines will keep calculating, and the sun will rise tomorrow. Sleep now. Let go. Good night.
See you in my dreams.